Good morning, mathematicians. Today we're going to be working on lesson 1.8. Our goal today is that we can classify quadrilaterals. So right now, finish the sentence, I will be successful when I can classify quadrilaterals. We're going to be going through a review of all of our shapes, and then you're going to be applying this within the lesson. Remember that parallel lines are lines on a flat surface that never cross or meet. Think of a railroad track that goes on forever. The two rails are parallel lines. The rails never meet or cross, and they are always the same distance apart. We also looked at the two L's in parallel. Those are examples of two parallel line segments. That should help you remember the word parallel. Perpendicular lines then, if lines or segments cross or meet each other, they intersect. Lines or segments that intersect and form right angles are called perpendicular lines or segments. So here are a few examples. FE and JK are parallel. These two lines are parallel. These ones intersect, but they are not perpendicular. But if we look here, these two lines are perpendicular. We know that because they look like they meet at a 90-degree angle, and the angle symbol is there. These segments here are not parallel, and they do not intersect. And so on. Let's give this a try. On your board, draw and label each of the following. A point called M, line RT, angle TRY, line segment XY, parallel line segments DE and KL, and a ray FG. Number 1, here's a point with M. Number 2, a line RT. Number 3, angle TRY would look like this. We have T, we have R, we have Y, with arrows on the end. Number 4, line segment XY. Number 5, parallel line segments. One is DE, the other one is KL, and finally a ray FG could look like this. F. Now let's take a look at polygons. We know that polygons are flat, two-dimensional figures made up of line segments called sides. A polygon can have any number of sides, because remember the prefix poly, or the part of the word poly, just means many. Gon means side, so polygons are shapes with many sides. They must have these two things though. They must be connected end to end and make one closed path, and the sides of the polygon do not cross. We know that endpoints like this are called the vertex, or if there's many of them, we say vertices. These shapes are all polygons. Turn and share with your partner, how do we know that all of these are truly polygons? When we look at polygons, we have special names based on the prefix for them. We know tri means 3, quad is 4, penta is 5, hexa is 6, hepta is 7, octa is 8, nona 9, deca 10, and dodeca is 12. When we think of polygons, we know the sides. We also know that polygons can either be convex or concave. Let's see how much we remember on this. What is the name of a polygon having 4 sides? What about 6 sides and 8 sides? Number 2 and number 3 you're going to do on your board right now. Number 2A, draw a convex hexagon. Think about what hex means and convex. Letter B, draw a concave octagon. And number 3, explain why the cover of this book is not a regular polygon. Go ahead and do that and then discuss as a class. We also know that triangles are a special type of polygon. Follow along as we read all about triangles. Triangles have 3-letter names. You name a triangle by listing the letter names for the vertices in order. So the triangle above has 6 possible names. That triangle looked like this, and each of the vertices were labeled A, B, and C. It could be called triangle BCA, triangle BAC, triangle CAB, triangle ABC, and triangle ACB. Triangles have different sizes and shapes. You will work with 2 types of triangles that have been given special names. The first is an equilateral triangle. This is a triangle whose 3 sides all have the same length. Equilateral triangles have many different sizes, but all equilateral triangles have the same shape. A right triangle is a triangle with 1 right angle or 1 square corner. A right triangle have many different shapes and sizes. Turn and share with your partner what does it mean for something to be an equilateral triangle and a right triangle. Go ahead. It's important to note that a right triangle cannot be an equilateral triangle because the side opposite the right angle is always longer than each of the other sides. So if we look at this triangle, it looks like it could almost be an equilateral triangle, but it can never actually happen. These 2 sides could be the same length, but the side that's across from the 90-degree angle, this one, is always going to be the biggest. Let's check our understanding of triangles. Draw and label an equilateral triangle named SAC. Write the 5 other possible names for this triangle. Draw a right triangle with 2 sides that are the same length. Go ahead and do this now. Turn and share your answers with a partner. Let's see how we did. During this unit, we also talked about quadrangles. We know quadrangles are polygons that have 4 sides. Another name for a quadrangle is a quadrilateral. The prefix quad means 4. All quadrangles have 4 vertices, 4 sides, and 4 angles. A quadrilateral could be a parallelogram, like these. A parallelogram means that opposite sides are parallel in each figure. These are not parallelograms, even though some of them might be quadrangles. This only has 1 pair of parallel sides, so it's not a parallelogram. This has too many pairs. It has 3 full pairs. And this has no parallel sides. Before we check our understanding of polygons and quadrilaterals, let's do one other quick review. You've seen a chart like this before. We know that all of these are considered to be polygons. Polygons, if they have 4 sides, are called quadrangles. Quadrangles can either be parallelograms or not parallelograms. The 3 types of parallelograms are rectangles, rhombuses, and squares. The 3 types of non-parallelograms are trapezoids, kites, and then other shapes. For each of these, we will turn and talk and then share the answer as a class. Number 1. What is the difference between the quadrangles in each pair below? What's the difference between a square and a rectangle? Turn and talk. What is the difference between a kite and a rhombus? And finally, what's the difference between a trapezoid and a parallelogram? Today you're going to be working on reviewing all of these different shapes. Follow along first. In our learning journey, we will be adding the date, and then we'll be doing Math Journal page 25. That page looks like this. It is a definition match, where on the left side you'll be given the definitions, and the right side is the shape. You'll read the definition and write the letter on the right for the shape it matches. Note that in the directions, it says here that some of the items in column 2 do not have a match. Some of these will be left blank. The second thing on our learning journey here says that we need to finish our math boxes. Then you do Math Journal, page 34. Notice it says only do 1 and 2. Here's page 34. Finally, you'll be doing Math Journal, page 54. You do this whole page. It's very important you read these directions closely. When you're done with all 4 of those things, your teacher will be checking that all are complete and accurate, and then we are going on to either Activity B, which is a Math Master page 31, or Activity C, which is a Math Master page, and then going on to Blend Space. Make it a great day.